The definite integral has been defined as the area under a curve between two fixed limits. Let's now consider the integral f of x, where the lower limit is still fixed, but the upper limit is now variable. That is because we are going to look at how the definition of an integral as the area under a curve is connected to the assertion that we are going to use later, that integration is the inverse process to differentiation. Since we are going to look at integration and its connection to the differentiation, we are going to create a function in a similar way when we were looking at differentiation. So I'm going to look at a function that is shifted from a value of x by delta x. So I'm going to look at f of x plus delta x. Therefore, since my f of x was defined in this way, so now I have my f of x plus delta x is going to be the expression from the same fixed limit a, but now up to x plus delta x. Now we can take x is definitely somehow is intermediate value between a and x plus delta x, since I considered that of course delta x will be positive, right? So x is going to be somewhere in between a and x plus delta x. So I can split this integral into sum of two integrals, from one from a to x and another one from x to x plus delta x. Now we see that the first part of this sum is our original function f of x plus an integral of f of u du from x to x plus delta x. Please note that I had to use in our integral the dummy variable u. I can't use the same. They are not the same. Although this x is variable, this x is variable, they are still different things. So I have to use different letter for my variable in the integral. So now I'm going to create the difference between f of x plus delta x and f of x. I have created this, and now I'm going to divide both sides by delta x. As you can see, once I will allow delta x tend to 0, we are going to have the derivative on the left side. So we have done rearrangement and we divided by delta x. Now we are going to look what happens when delta x tends to 0. So we take limits from both sides, and when delta x tends to 0, we are getting the derivative of f of x by dx on the left side. On the right side, since delta x tends to 0, then the value of this integral is going to be f of x times delta x. So when delta x tends to 0, where our limit is going to be equal to f of x. So changing back f of x to our integral, we can see that derivative of our integral from a to x is going to be the function itself. So here you can see this connection that we are going to use quite a lot, that integration can be considered as the inverse of differentiation. You can see that they cancel each other. So since our low limit a was arbitrary value, so actually differentiation does not have here any unique inverse. Any two functions or any two intervals that differ by an arbitrary constant, say c, are going to satisfy this equation. Therefore, integral of f of x dx is going to be f of x, capital F of x plus c. So you indeed, if you will differentiate the right side, you are going to get our function f of x back. So I hope this a little bit of theory will make it a little bit clearer where this assertion about integration being the inverse of differentiation come from. That is the end of the video, and thank you for watching.